Hello everyone. Jude sent me these questions. Now these are specifically quite difficult questions. Now anytime that people send me these sort of things, I'm going to do them as a video if I can. Okay. Now please forgive, there's a pretty big lag on this it seems, so yeah, just bear with me. Now when it comes to doing or dealing with these, what we need to appreciate is that there's always a relationship between the 2 and that 16. And by that I mean that 2 to the power of 3x minus 1 is equal to 2 to the power of what? Which makes 16. By that I mean, I know that 2 squared is 4, 2 to the power of 3 is 8. 2 to the power of 4 is actually equal to 16. And I can rewrite 16 so that these two now have the same base. Just fix that focus. Now that they've got the same base, I can now say, well, that means that if 2 to the power of that equals 2 to the power of that, that means 3x minus 1 must equal 4. And if we work it out, 3x equals 5, x equals 5 on 3. Now let's have a look at this one. If we have 2 to the power of x, 2 to the 2x divided by 2 to the x plus 1 equals 8. We're doing the same again with that 8. We're turning that into a 2, into a power of 2. So that means 2 to the 2x over 2 to the x plus 1 equals 2 to the power of 3. They like to use 2 because it's easy to work with. So we can rewrite this now and say, well, that means, because this is a division, that means 2 to the 2x, I'll put brackets around it, I'm not sure why, minus x plus 1 equals 2 to the power of 3. Let me just simplify this out. So that means that's 2 to the 2x minus x equals x, and then that minus brings out to that, minus 1 equals 2 to the power of 3. Therefore, x minus 1 equals 3, and x equals 4. So the trick here with all of these is that you need to make sure that you convert them all to have the same base. And only then, that way you can compare the exponents. Now this last one here is like triple tricky. Now, because you're expected to do everything that you did before, but it's just more complicated. So best, again, we need to convert all of these numbers into bases of 2. And you'll notice they're very nice numbers. So we've got 2 to the x plus 5 divided by 8 is 2 to the power of 3 to the x. And then we've got 4, which I know is just 2 squared. I'll just put brackets around it, to the x minus 1 over 2 to the 2x minus 1. Now, if we know our index laws when we're dealing with brackets, that's just times. So that we're just going to rewrite this as 2 to the x plus 5 over 2 to the 3x. And this is 2 squared times x minus 1, so this will be 2 to the 2x minus 2 over 2 to the 2x minus 1. Now these are divisions again, so we can keep on going and keep on simplifying. This is 2 to the x plus 5 minus 3x. And this is 2 to the 2x minus 2 minus 2x minus 1. Now you notice I'm putting, because we're bagging the whole thing. We need to make sure that you bag it, because otherwise the tendency will be just to take away the 2x, but not to take away the negative of the negative 1. Simplify 2 to the x plus 5 minus 3x. So that is minus 2x plus 5 equals 2, and this is 2x minus 2 minus 2x, so they'll cancel out. Minus 2 minus minus 1 is minus 2 plus 1, which is negative 1. So that means now they've both got the same base, and you'll see these negative indices and you might want to deal with it, but you actually don't need to, because they've got the same base. We can say negative 2x plus 5 equals negative 1, and so that means that negative 2x equals 1 minus 5, which is negative 6, and x equals 3. So again, summary, the trick is you need to make sure that if you're comparing these exponents, you want to cancel out the bases by making all of the numbers in here to have the same base. Okay.